Hi, everyone. So we're going to do this lab via video. Unfortunately, I can't be with you today. I'm sick, and I really want us to, to do this lab, even if we can't do it in person, even though we can't really do it hands-on. You can watch the video, which, by the way, if you haven't watched the video, you need to watch that first before we jump into these calculations and data and everything. So if you haven't watched the video, watch it now and then come back to this, okay? All right, so what we're going to do in this lab is we're going to determine the molar volume of a gas at standard temperature and pressure. Now, to be clear, guys, we know actually already that the molar volume of any gas, 1 mole, is 22.4 liters, okay, at standard temperature and pressure. That is true for any gas. What we're doing in this lab is we're actually determining that with our experimental values, okay? So in the end, we'll check our work against the molar volume of a gas that's accepted. In other words, 1 mole is 22.4 liters. We're going to see how close we get to that value, okay? In this experiment, we're using this reaction. We're combining magnesium with hydrochloric acid to form magnesium chloride, which, by the way, is soluble and it just dissolves in the water. You don't see this forming in the video, but you do see the hydrogen gas forming. You see the bubbles forming, and we collect hydrogen gas. That's the gas that we're going to use to determine the molar volume of a gas. Remember, all gases act the same, at least ideally, anyway. Okay, so let's move on. What are the questions here? Okay, now when you watch this video, and by the way, a eudiometer is just a fancy name for the gas collection tube that was used in the video. So, eudiometer, no big deal. What are the two gases that are collected in the eudiometer? Well, the first one that we can mention is hydrogen gas. And the other gas, which is not as obvious, is water vapor. Okay. Water vapor. Water vapor collects in the tube because we're collecting the hydrogen over water. So obviously there's water evaporation happening within the tube. So the gases, there are two gases actually that are being collected, hydrogen and water vapor. Okay. All right, this next question, what is pressure and what is temperature at standard temperature and pressure? So the pressure in kPa is 101.3 kPa, all right? Standard temperature is 273 Kelvin, okay? So in other words, 0 degrees Celsius. This next question is a practice question that has a lot to do with what's done in this lab. In fact, if we work through this practice question, you should be able to do the calculations later for using the data that we got from the video. Okay, so anyway, in this practice question, we're collecting 35 milliliters of chlorine gas over water at 24 degrees Celsius, and the atmospheric pressure is at 99.1 kPa, according to a barometer that was read. All right, fine. The vapor pressure of water at this temperature is 2.99 kPa. So this brings us to something that we have not talked about in class. What that brings us to Dalton's law of partial pressure. This is something that we haven't talked about in class. I held off until this lab. Actually, one of the reasons I held off on it is because it's so easy to understand. All that it says is that if you have more than one gas in a container, all of those gases combined are contributing to the total pressure. So in other words, the pressure total equals the pressure, let's say, of gas 1 plus the pressure of gas 2 plus the pressure of gas 3, and so on and so on. In this lab, and in this example problem, we're collecting two gases. In this problem, we're collecting chlorine gas, and it's being done over water, so we are also collecting water vapor. So in other words, the total pressure, which by the way is atmospheric pressure, hope you can read my writing, equals the pressure of the chlorine gas plus the pressure of the water vapor. And the pressure of the water vapor is given to us. Also, where is it? I'm looking for there it is. Atmospheric pressure is there. Okay, so the pressure of the chlorine is just going to be the difference between the atmospheric pressure and the pressure of the water vapor. I'm just going to calculate that right now. All right, so the pressure of the chlorine in this container is just going to be 96.1 kPa. All right, so I just set this up right away. We're going to use the combined gas law to find the volume of this chlorine that was collected under standard temperature and pressure. So there's the combined gas law. These are the values that go into that. And the volume calculates to be 31.5 milliliters. Okay, let's move on to the experiment, and here we go. The experiment that you watched in the video was done slightly differently than we would have done in class. All right, essentially, I'm just going to get rid of this row right there because I'm just going to give you the mass of the magnesium that we used. All right, so actually, this was given in the video. There were two trials that were done in this video. We're just going to go with one trial. So the data that goes with one trial, the mass of the magnesium that was used was 0.0342 grams. Okay. The other data that was taken, the temperature in the water tank was 21.2 degrees Celsius, 21.2 Celsius. Okay. The barometric pressure was not given, but I'm going to give it to you right now, 97.4 kPa. All right, we will come back to the vapor pressure of the water at that temperature. Okay, we'll come back to that in a little bit. The volume of the hydrogen that was collected was 36.5 milliliters. Okay, that's the data that we need. Okay, now when we do these calculations, guys, and I'm going to expect that you do this, all of these calculations must be done to 3 significant figures, okay? No rounding shorter than 3 significant figures, and don't give me more than 3 significant figures, okay? So anyway, going with 3 significant figures, the mass of the magnesium was 0.0324 grams. If you do that calculation, that will come out to be 0.00 0.141 moles of magnesium. So this is magnesium, this is magnesium, okay? All right, the balanced chemical equation for this reaction is we're combining magnesium with hydrochloric acid. We're making magnesium chloride, okay, and hydrogen gas. So this is the balanced chemical equation. So notice that the mole ratio between magnesium and hydrogen gas is 1 to 1. Okay? If that is the case, then I hope this is very obvious to you, because I should probably just let you guys do this on your own. But here we go. The number of moles of hydrogen that would be produced is 0.00141 moles hydrogen. Okay? That should be very obvious, because that's a 1 to 1 ratio. All right, now, what was the barometric pressure in kPa? It was 97.4 kPa. The next part of this is we need to find the vapor pressure of the water vapor in the container, in the eudiometer. How are we going to do that? We are going to do this. Here's some mercury. All right, now we need to convert this to kPa. So this is a skill that I'm going to ask you to be able to do. You're not going to need to memorize the equivalencies, but you sure should be able to convert from millimeters of mercury to kPa. I'm going to do that right now. All right, so that water vapor pressure came out to be 2.49 kPa. All right, so now we want just the pressure of the hydrogen. All right, so let's work through that. Now remember, we're going to use Dalton's law of partial pressure to solve this, and the total pressure is going to be the atmospheric pressure. Okay, so that comes out to be 94.91 kPa for the hydrogen. All right. Okay, I'm going to leave the rest up to you. I've done quite a lot here. One of the reasons I wanted to work through this with you like this is because we had never worked with Dalton's law of partial pressure. But I hope that you find that to be very simple. It should be very simple. But you can do the rest of this analysis. If you're not sure what to do there, look back to the practice problem that we did in the pre-lab, and also do number 2, according to your data, what is the molar volume of a gas, all right? Again, now, just if you're not sure how to do that, think about what liters per mole means, okay? And make that calculation, okay? Last thing then, I would like you to calculate your experimental error. Again, if you need a refresher on that, this is the formula for experimental error. All right, the rest is up to you. Complete this work and turn it into Shobi. Actually, no, you're going to work this out on a hard copy, so you'll hand this in next time I see you in class. Thank you. We're going to go to this table here, and this I attached to the back of the worksheet. And all we need here is the temperature of the water tank. So it was at 21.2 degrees Celsius. That puts us right about there. So the vapor pressure is 18.7. Now this is in millimeters of mercury, so we've got to keep that in mind. We're going to write this down, 18.7 millimeters.